Welcome to a lesson with Dr. Powell. Let's look at two different ways that we can compute the cross product between two vectors using quaternion type ideas. Let's suppose that u is equal to negative I plus j plus k, and v is equal to I plus 2j plus 3k. And let's try to compute u cross v. This is going to be the imaginary part of the u bar. U bar is just the negative of u, but it's also the imaginary part of just u times v. The real parts of these are different, but the imaginary parts are the same. So let's just do that to keep this in line. So kind of a simple way of doing this, for one, is we can look at the coefficients here, negative 1, 1, 1, and let's just list them out for u, this for starters. Negative 1, 1, 1. This is what's first, u. Then v, do the same thing with the coefficients right here. 1, 2, 3. Okay, next, let's eliminate, not do things that are diagonal from each other, but do everything else. So let's do negative 2, negative 3 here, multiplying. Here, let's do 1, and then go over here to 3. Notice I'm omitting the middle. Then I have a 1 and a 2. Okay, then I'm done. Ow, I'm really almost done with the cross product, because all I have to do now is kind of change things up a little bit. I'm going to make the top over here, I'm just going to keep the sign of what's up there, and I'm going to change the sign of what's down here. Now, why do I change the sign? That comes into effect because thinking of these as I, j, and k, in reversing the order, by being up here or here, it just reverses order across between I times j or j times I. Down here, I'd change the sign. I'm gonna have to change the sign one more time, but it'll be okay. I'll do that at the end for j, because really the signs are opposite. Really, I should for j, which comes from an I times a k or something like that. I should actually make this. I should actually change the sign of this and keep the sign of that. But I'll just to make it simple though, keep the signs up here the same, make those negative, and we'll just adjust j at the very end. That's it. Okay, so just quickly get these numbers, and then we just add across to get our different I. So these two together will give us I. These two together will give us j, thinking like I, k, and k, ki. So these two right here for I, these two right here for j, but we're going to take the negative of this, as I mentioned, so we'll give us negative j, say, and then these right here will be for k. All right, so just add 3 and negative 2, that's I, and negative 3 and negative 1, that's negative 4, but we're going to take the negative of that, so just plus 4j, and then negative 2, negative 1, that's negative 3k. And we're just using regular quaternion multiplication, thinking about it in order to get this result. And we can check this to make sure that this is accurate for the cross product by just taking dot products with what we had originally and making sure that they're 0. So thinking of these as vectors, let's see, negative 1 and 1 is negative 1, 1 and 4, that's 4. And then we have 1 and negative 3. Look, it's orthogonal. And we could similarly check for the other one, because if we add, because that was 0, check for the other one and just kind of verify. So this is the first method that we can use to multiply quaternions, or take a cross product, that is, at least focusing on the imaginary part. The standard procedure that's usually taught, though, is to make a matrix with an I, j, k, and then write out in order negative 1, 1, 1 for u, and then for v, 1, 2, 3. And then to figure out what the coefficient of I is, we ignore the column. I mean, we ignore the column with I and the row with I, and we just look at this and look at diagonals. We say 1 times 3 minus 1 times 2. So we get 1 times 3 minus 1 times 2. And that's going to be the coefficient of I, which happens to be just 1. So it's just I. Okay. Then for J, do something similar. Ignoring this column and this row, we just look at there's -1 and 3 and that 1 and 1. So we have -3 minus 1, which would be -4. But again, for the same reason over here, we changed the sign of J, so it's positive. So J always gets to be changed, plus 4J. Then K, we do this diagonal minus that diagonal. So -1 times 2 is -2, -1, so it's -3. And again, we get the exact same result. There are multiple ways, methods for computing cross product. So those are 2 ways of doing so. Thanks for watching.